Hello, everybody. Welcome to SVS205. I hope that on day 4 of reInvent, you still have a little bit of space in your brains to take in something new, because I know it's been a really packed and awesome reInvent this year. So I'm super excited that you chose to join us today. My name is Emily Shea. I lead our application integration go-to-market team here at AWS. And I'm going to be taking us through my talk on getting started building serverless and event-driven applications. I'm also super excited this year to be joined by one of my colleagues, Naren Gaka, who's going to close us out with an awesome live demo of Application Composer and some of the really cool features that are available in that. So I'm super excited to jump into it. Maybe just a little bit of preface. I love giving this talk because it is very much drawn on my own personal experience. So you're going to hear a lot about kind of the trial and error that I faced as I was learning about serverless, and hopefully I can save you from a little bit of that and give you some of the best practices to get you off to a great start. This is a really good talk for somebody that is brand new to building applications, starting to get into developing and getting into the cloud, and wants to learn about serverless and really AWS native ways to build applications. It's also a really good talk if you are someone that's coming from building applications, but maybe from building them on servers or containers or a different type of kind of model of different services that you might be using, and you want to get started into serverless, because we're going to be talking about some of the parallels there. So with all of those, in all of those kind of personas or backgrounds that you're bringing to this talk, there'll be something in here for you today. So I have absolutely no doubt that in this room, there are so many great application ideas, so many ideas for new features that you want to build maybe at your work and kind of add on to an application that you're developing, or something that you want to build for yourself and personally you want to get going with. The one thing that's really constraining us is just the time and the resources and the energy to get those applications out the door and into production and in use. And the really cool thing that I want to show you today is how serverless services and event-driven architectures can combine to help you take those ideas that you have and turn them into applications even faster, and just get those ideas out into the world. Give you a little bit of background on me. So I mentioned my name's Emily Shea. My background is actually not in technology at all. So I started and spent a lot of my educational career in Chinese language. Still have a really big passion for learning and speaking the language. And I got started at Amazon in about 2016. I was super interested in AWS and the cloud and getting to know the technology, and so I started working on certifications, did a little bit of kind of coding boot camps online, and just started to build serverless applications. And I really made a point to build something that was useful to me, and I feel like that helped my knowledge kind of stick really well and gave me something cool to share on stage with you today. So I've been in a bunch of different roles at AWS, all around serverless and application integration. Currently, I lead a team of specialists working on application integration services, which is a lot of the ones that we're going to be talking about today. So in this talk, I'm going to draw on my own personal experience, and I'm going to take you through choosing AWS services, through the tools that I use to build and deploy and test those serverless applications, and also critically about how to evolve your application and increase complexity and more services over time. And lastly, we're going to close out with that live demo of Application Composer. And finally, of course, the big point that I'd love you to take away from today is the fact that serverless and event-driven can help you build your applications even faster with the power of the cloud. So I'd mentioned that I was just getting started, just getting into coding and building serverless applications. And I wanted to build something that would be useful to me so that I could really kind of help those ideas sink in. The idea that I had was based on my background in Chinese language and the fact that I was finding it really hard to dedicate time and devote time in my day to practicing Chinese. And so I thought it'd be really cool if I was able to send myself daily reminders with a Chinese vocabulary word and just give myself that prompt to remember to study. The pieces that I would need for this application would be some type of daily schedule to invoke this application. I need some form of a logic to pull from my database of vocab words and select the word that I wanted to send out that day. And then finally, I would need some kind of messaging system to be able to send that message on to me, the user. So that was the application that I was building. There's loads of different things that you could get started with if you just want to kind of jump in and start playing around with ideas. A couple cool ones is maybe an app that checks the weather and recommends what to wear, or a workflow that allows you to take a file or an image and process that with some ML and AWS service. Also a cool one that you can actually check out on the expo hall today is a live streaming or on-demand video application. So the serverless developer advocate team built serverless video as a demo that you can build and work with. But what I want to emphasize is the fact that the services that we're going to be talking about today are not just in use for kind of like personal applications or small things that you want to build. These are in use by some really massive AWS customers for very large-scale business-critical production applications. Some cool ones are PostNL, which is one of the largest logistic companies serving the Netherlands, processing over 1 million parcels per day. Nationwide Children's Hospital uses these services to automate workflows for petabytes of pediatric cancer data. And lastly, Taco Bell has a really cool use case around taking the order events from their delivery partner applications and sending those over to the point of sale systems. So some really major applications that are using the services that we're going to walk through today. So I'm going to start with just introducing our toolbox of services that we have for serverless. But before we jump into that, I also want to just take a minute to make sure that we're all clear on what is serverless and why serverless. So serverless is really a new concept that we've built just because we found that customers were spending so much time on the undifferentiated work of managing servers. So traditional applications, if you wanted to build a new idea and you wanted to take a new application to production, you would need to provision and maintain and scale those servers and that infrastructure that your application runs on. And what we did at AWS is we said, hey, I think we can automate that in the cloud and allow you to just upload your code and just build the business logic that is most critical and most unique to your application. So with serverless and all the services we're talking about, you get no server management. Those services scale up and down automatically based on the usage of your application. Pay-for-use billing model, so if there's no traffic hitting your application at the time, you're not paying for it. And also built-in features and functionality that are constantly adapting and constantly kind of getting better around you as we launch new cool things. Ultimately, if you're only coding the things that make your application very unique, then you're able to get that out there and to get that into production even faster. So I'm going to use kind of the traditional 3-tier application that you might be familiar with, you might have built with in the past, to just kind of show where the AWS serverless services fit into this kind of architecture. So starting at the bottom with our data layer, Amazon S3 Simple Storage Service is a great place to use for object storage. So files, images, those kind of things are a great place to put in S3. For databases, Amazon DynamoDB is a great database that is really optimized for using with serverless architectures. And I'm going to talk a little bit more about DynamoDB and what makes it cool in a little bit. Moving on up to the application logic layer. So here we've got AWS Lambda, which you might be familiar with, serverless functions. So you can take a piece of code, put it into Lambda, and every time that Lambda function is invoked, that code will be invoked, and your Lambda function will scale up and down as needed for the application traffic. Next, get into integration services. I mentioned this is what I get to go to market for in my current role. So these are a bunch of really cool services that provide very purpose-built integration features within your serverless application. So think about things like AWS step functions for building workflows and orchestrating a number of AWS services into a particular order. Simple queue service for building message queues, Event Bridge for event filtering and routing, and simple notification service for sending messages. All of these pieces, maybe you could code a bit of this on your own, or you could choose a purpose-built service that will have all these features of error handling and retries and all these things built into it right out of the box. Lastly, as we get up into the front-end presentation layer, we're going to need an API gateway to allow us to serve API endpoints so that the users in the UI can interact with the back end of our application. We also might need authentication. So Amazon Cognito is a great service if you want to create maybe some protected endpoints or require some auth before interacting with those back-end resources. And Amplify. Amplify is a really easy way to have static content, so the HTML, CSS, and JavaScript files that make up your front-end UI. Amplify is a great way to serve those and to serve those in a very distributed global way. So this is the entire kind of stack that we have within serverless. I should say not quite entire because you can really pull from all kinds of AWS services in AIML and lots of different things that you can pull in here. But this is what I would consider kind of a core set that you can really do a lot of powerful application building with amongst the serverless services. So coming back to that very basic kind of conceptual architecture that I had for my application that I wanted to build, let's go ahead and take this and apply those AWS services to this application. So here at its most basic, the application that I was building, I've got Amazon Event Bridge, which is sending a scheduled daily event to a Lambda function. That Lambda function is then running a bit of logic to pull from a list, just a CSV file at this point, of all of my vocabulary words. It chooses a random one, and it sends that off with SNS over to a text message, and I get that on my phone every day. So this was the most basic and probably the first application that I ever built with serverless, and it was really kind of simple and easy to reason about, and a good way to get started. So within that, this plus just maybe a little bit more is pretty much all the code that I needed to run this application at this point. This is just taking a look into one of those Lambda functions. I'm importing Boto3, which is the SDK for working with Python. I'm instantiating an S3 and an SNS client so that I can make calls to those services' APIs and interact with them. Then I've got my Lambda handler, and the Lambda handler is the piece of the code that's going to be invoked every time that this function is invoked. And it responds to the event. So in this case, it would be that daily scheduled event. I've got a little comment where I would make that call out to S3 to retrieve that CSV file. I assemble that, the word that I was chosen into a message that gets sent out. And then I've got a little bit of error handling wrapped around this call to SNS to publish that message. So a really simple bit of code, and this is all that you really needed to power the application at this point. So that was the application at its most basic. Now, before I get into kind of evolving and adding complexity to this application, I think this is a really good point to start to introduce some of those tools and really the developer tool chain that comes into play around serverless applications. Because this will really make your experience of building serverless applications that much more enjoyable if you have a really strong tool set around you. So I've got some examples of some of the ones that I found particularly useful. So first off, it absolutely makes sense to just jump into the console and start playing around with stuff. This is a great place to just learn about what's available, learn about what different features the services have and how they interact with one another. So the console is a nice place to dip your toe in, but I definitely recommend that you evolve beyond just deploying directly in the console and start to use an infrastructure as code framework pretty quickly as you're developing serverless applications. So what's really cool about an infrastructure as code framework is it allows you to configure all of those resources, and you're probably going to have a fair number of services involved in a serverless application within a particular just an infrastructure as code framework. And this allows you to know that you're deploying the application in the exact same way, configured exactly as how you want it every time that you deploy that application. There's a couple different options that you have for infrastructure as code with serverless. One of them, and the one that I'm going to be referring to, is the serverless application model, or AWS SAM. Another one that's really popular with folks is the Cloud Development Kit, or CDK. There's also some great partner tools out there. So Serverless Framework, Terraform, all these are options to help you define that entire application as code. So we can take a quick look at an example SAM template. So this is the template that I would have used for that very basic version of the application that I showed you. We've got some metadata about the template, and then we get into defining our resources. So the main resource that I'm showcasing here is that Lambda function, the send text function. We define the type, so this is a serverless function. And then we have a couple properties. So we point to where the Lambda handler is located in the code, the runtime, which is Python in our case. This is the next part about policies is actually something really cool that SAM does for you. Basically, SAM is built on top of CloudFormation, but CloudFormation can get very verbose when it comes to defining all the different pieces within the serverless application. And so what SAM does is it abstracts some of those verbose pieces into really simple 1 or 2 liners that you can use in your SAM template. So in this case, I want to be able to define a IAM policy to allow Lambda to talk to SNS and to publish messages. And so I just use a SAM template, or a SAM policy template that's just that one line of SNS publish message policy, and I point it to the topic name and the SNS topic that I want to call. So a really brief way to describe what you're trying to build. Passing some environment variables. And then the last bit is that thing at the end. It says event. And this is all of the infrastructure as code that I would need to define that event bridge scheduled event that we needed to trigger the Lambda function. So this creates an event bridge scheduled event that runs on a particular schedule. And I just needed maybe a couple lines to define the S3 bucket and the SNS topic below, but a pretty brief definition of that application that we built. So you can absolutely define your SAM templates by hand and kind of write those out yourself. Or you can use a really cool tool that we launched last reInvent, which is AWS Application Composer. It's a visual designer, drag and drop those services that you're building your application into the Application Composer. And then you can hit export, and it gives you a SAM template right out of the box. This is the part that Naren's going to focus on at the end of our talk. And he's also going to take us through some of the really cool things that launched literally this week around Application Composer. So this service is moving fast, and there's some cool stuff that's coming out there. So we have a infrastructure as code template. All of our application is defined as code, and we've got our function code. The last thing that we need to do is deploy that application. And the cool way to do this is with a CI/CD pipeline. And I think that, especially as you're building a serverless application, you're making a lot of changes to that infrastructure, it's really helpful to have an automated deployment pipeline so that anytime that you make changes to that application, it's automatically getting synced up and deployed to the cloud, because that'll allow you to move so much faster. You could use code pipeline for this, GitHub, and this is kind of the flow that would take. So defining your application in infrastructure as code, uploading it to a repository, that upload to version control triggers a new build, and that deploys it up to the cloud. Another big topic within serverless is testing. So a lot of people get it started with serverless, and they might get a little frustrated because they're used to be able to test the entire application on their local environment or on their computer. And they say, why can't I do that with serverless? So I have a couple tips around the best way to test your serverless applications for the best results. The first piece is that you are probably going to have a few Lambda functions that do have some complex code logic within them. And for those ones, it does make sense to write a unit test and to test that function code. Here's an example unit test. This one is, again, for that function that we talked about earlier. So it's using the unit test framework. It's mocking those calls to S3 and to SNS so that we're not needing to actually make calls out to the cloud services. And then it's running the test and testing that Lambda handler and seeing if the response is as expected. So for functions that do have a lot of complex logic within them that you're coding yourself, this type of model does make sense. But you can see how you start to introduce a little bit of complexity for yourself when you're mocking a lot of service calls. Because the cloud services, there's a lot of different ways that they could respond. Are you really using, or what's the word I'm looking for? Are you really expecting all the types of things that they might give back to you? It can be really hard to perfectly mock and simulate a cloud service. And so if it's really about testing the service integrations that you're looking for in this piece of your application, then it makes sense to just get that application into the cloud and run your tests in a development environment in the cloud. One of the things that we have built within kind of the SAM toolchain to be able to help you do this even faster is SAM Accelerate. So SAM Accelerate, what this allows you to do is actually just quickly sync new function code up into a development environment. And this will allow you to move very quickly. You don't need to wait for an entire application deployment, entire resource and infrastructure deployment of your application. You can just sync up that function code and get your testing cycles to run that much faster. So those are a little bit of the tips that I have around the testing and deployment and definition of applications and how you can build a really strong and effective tool chain for yourself for serverless. So we have a basic MVP. We've got a tool chain set up that will allow us to move super fast. Now let's get into how we might evolve this application to be a lot more complex and use more of those services in the toolbox that we pointed out earlier. So we started from here. Now, one thing that I was getting requests from was, this at this point just sends text messages to me. I had some friends that were interested and said, hey, I would love to be able to get these texts as well. I'd love to subscribe to this service. So I saw the opportunity to build out the ability for other people to log on to a website and subscribe or unsubscribe. And so I added this additional functionality. So the stuff on the right is pretty much the same. The only small change is that instead of text messaging, I've swapped it out to email just because I'm reaching more people. But then the entire left side is all brand new using a API gateway to have API endpoints where people can reach UI and subscribe or unsubscribe. Using DynamoDB to store all of the user data and figure out what kind of level of Chinese vocabulary they want to subscribe to. And then I'm also serving that content up through Amplify to give them a nice UI that they can use to interact with my application. Here's a screenshot of that UI, and shows some of the things that you can interact with and API endpoints that you could hit on there. And at this stage of my application, one of the really cool things that I added was a database with DynamoDB. So early on, all I was doing was pulling a full list of Chinese vocab words as a CSV file from S3. And that was pretty simple for just a once-a-day kind of pull of data pull to get that information. But now that I've got users that are going in and they're updating their subscriptions, or they're unsubscribing, or they're creating new users, the data use cases became much more complex, and it made sense to add a database in. DynamoDB is particularly cool in that it's really optimized for serverless. So the pay-as-you-go pricing model scales automatically. You can also use IAM authentication and the AWS SDK to interact with your data. So it's a little bit different from a database that you might have worked with in the past. The other thing that's really key to know as you're getting started with DynamoDB is just the importance of planning your DynamoDB access patterns around the way that DynamoDB is architected. So this is one that I've kind of gotten into, and it's helped me a lot as I build out more DynamoDB data models. So you might be familiar with a SQL data structure like this one. So you've got your entire database on a single server, and you've got multiple tables that are kind of grouped around similar information. So you've got a users table and a lists table, and if you want to find out which users are subscribed to which lists, you might do a join of those two tables together. And that's a typical kind of SQL model that you might be working with. Now, what DynamoDB does that's very cool, that kind of contrasts with this model, is with this model, if you wanted to have more data or serve more requests, the only way that you really have to scale is to make that server even bigger. Whereas with DynamoDB, they've really built around the concept of let's get you to scale automatically first. And so they take your data and they automatically shard it across multiple servers. So you never really think about whether you need to scale up and, or need to configure a very large database to start with. So it's a very cool thing that DynamoDB does. But one thing to keep in mind is that you'll want to group your data in item collections to make sure that the data that you're reaching for the most often is in the same location and the DynamoDB is storing it all together. So think about your access patterns. For my case, I wanted to have users to be able to log in and to see their subscriptions and to update those, maybe add subscriptions or unsubscribe. So I want to be able to query by a user and then return all of the subscriptions that they have. So this is the way that I've structured item collections within my DynamoDB table. Now, if you want to dig into this topic and see some really cool examples of this, I definitely recommend checking out Alex Debris' The DynamoDB book, because this is a really great primer on kind of how to kind of figure out how to approach this and build your own data models. So at this point, I saw an opportunity to say, hey, let's make it a little bit more interesting for the users of this application. They have the ability to subscribe and unsubscribe from the emails and Chinese vocab words that they're getting. But why don't we give them the ability to save some data about themselves, so maybe update, have a user profile, be able to change their username. And really the path for this is I want them to have the ability to save more interesting information about the daily word they're getting. So maybe have an example sentence or to store a quiz result if they want to take a quiz on the daily word that they have. So I wanted to be able to have more kind of data about a user and store it in a way that's secure and only accessible by that particular user. With this, I introduced Amazon Cognito, and then both of these API endpoints for updating user data and getting user data are both protected and require auth through Cognito for this pattern. And these are some of the UIs that I built. These ones and the previous one that I showed earlier are all built in Vue.js and served through Amplify. So I've got user profiles and the ability for people to click in and update their profile settings or update their subscriptions in the application now. So that's the application pretty much as it stands today, but I'm always thinking about new ways to take new AWS services or new features that we're launching and integrating them to the application. And that's kind of my tool for learning about new serverless services. So here's some of the one or two of the ways that I've been extending this application recently. One of which is that I had a really big feature request from a lot of people that were using the application that they wanted to not only be able to read the words and see the words, but they also wanted to be able to hear them and get some of that pronunciation audio. I thought about this for a long time and couldn't figure out, like, do I just go hire people to go say, like, speak the words and be able to record them? And that seems awfully labor intensive. Until I realized that Amazon offers Poly, which allows you to take text files and be able to generate audio files off of them. So I had a ton of words and vocab lists that I needed to run through Poly, and I needed a way to just kind of iterate on those lists and save all of the audio files into S3 so that I can serve those from my front end. Now, the service that I used for this is AWS Step Functions. And so Step Functions allows you to assemble AWS services into a workflow and make sure that you're taking steps in a particular order and then taking the outputs of those and moving on with the workflow. So in this case, my Step Functions workflow, it starts out with a Lambda function that reaches into DynamoDB and pulls the word list. Then it starts a map state where it iterates over a batch of words, and it calls Amazon Poly to generate that audio file. Then it takes the audio file key and saves that to DynamoDB so that my front end knows where to look for that audio file to be able to serve it to the end users. Then it has a wait state. And the reason it has a wait state is because the Poly API has a rate limit. So this is a great way to avoid running into throttling or APIs that have limits, is to introduce a wait state within your Step Functions workflow. And then finally, it goes back and says, are there more words to batch through? And then it starts the whole batching process over again. And here's some comments to tell you exactly that. But so this is the workflow that I built around step functions and poly to be able to add this new feature to my application. And it was super quick to be able to build this. And again, very little kind of code to write, but some really cool functionality that you could build by assembling various AWS services. The next thing that I'm thinking about using some of Bedrock and also the Party Rock kind of playground that we built around Bedrock is right now I have the ability for people to look at example sentences for the daily word, but they have to click out to a link and go see an external dictionary website or something to see some random example sentences on the internet. And I think it'd be really cool if I instead was able to generate my own sentences and attach those to that word so that people can view those. I wanted to see if Bedrock would be a good solution for this and to be able to ask Bedrock and say, hey, I've got this Chinese word. Can you generate a handful of example sentences and return them back to me? Before I wanted to kind of go in and actually write a bunch of code and start calling the Bedrock API, I just went into Party Rock, which allows you to just kind of test some ideas against Bedrock. And it generated this application for me. And so far, I've asked some native speakers, and they said that there's some good sentences that are sounding really good and some that maybe need a little bit of iteration and prompt engineering to get the right responses back. But it seems like this is going to be a really viable way for me to add example sentences. And it was cool to be able to just test this idea out in Party Rock. And now I can go build that and maybe build a step functions workflow that calls out to Bedrock and add that into my application. One thing that I often get questions about as I'm taking people through this application is what is the monthly cost associated with this app? So I've got a couple stats about the traffic for this application. Again, this is just kind of for my own personal learning, and so it's not enormously massive. But there's a decent amount of people that are on there and folks that have attended past sessions or wanted to subscribe and learn Chinese. And so this is kind of roughly what this application sees over time. And the cost is shockingly low. It is less than $1 because I'm still below the free tier for a lot of these applications. But I also think that this is a particularly great use case for serverless, where the most times that my application is frequented is just that one time a day where I'm sending out all of those messages and sending people their word of the day. And then the rest of the time, that application does not need to be running, does not need to be kind of having unused capacity. And so I think this is a particularly well-optimized use case for serverless. So I wanted to end my portion just sharing a couple of the best practices and tips that have helped me along the way as I've been learning serverless. First ones are all around developer tooling. So building with a visual designer like Application Composer. Also, Step Functions has Workflow Studio that's integrated with Application Composer, so you can build your workflows visually. That's a really nice way to get started. And then also really cool is that those export in infrastructure as code template, so you can get running with that and deploy that quickly. I'd also highly recommend that you get started early with an automated deployment pipeline. This will make all of your kind of building your application and evolving it over time really, really smooth, and I really enjoyed working with this. Lastly, there's definitely occasions where you'd want to test some complex function code, but I definitely recommend testing in the cloud if you're trying to understand how services interact with one another. And then my other tips are around application design. So as you can see with this example, I've really started small with a simple MVP and taken that and evolved it in complexity over time and added new services. And that's one of the really cool things about serverless is that it is super extensible with if you've got events that you're emitting that you want to build a new feature on top of, or you've got a workflow that you want to add a new step into. The extensibility to really evolve to meet new and changing requirements is one of the biggest things that when I talk to customers in my day job is one of the things that keeps them coming back to serverless. And also, as you think about DynamoDB, planning your database access patterns, organizing your DynamoDB tables around item collections is going to help you have a really nice data model that will sustain your application over time. So the QR code, we'll bring that up again towards the end. But with that, I am happy to pass over to Naren to take us through the demo.
Thanks, Emily. As with anything at AWS, let's start with something with you, right? With you as in customers and customer requirements. Let's pick one of the customer requirement today and see how we can go about building that using AWS Application Composer, serverless services, and a bit of AI-enabled coding companion as well. So as we see on the screen, let's pick up one of the requirements wherein we have a bunch of documents, let's say. How do we go about summarizing them and saving them in a backend persistent database, and also built an API so that our users can use either a web application or a mobile application and access that API, access the summary results which are stored in a database. So if we understand the core of this particular requirement, we see two flows. One is an asynchronous flow wherein users submit or upload the documents in our storage service. They need to be picked up by a processing engine or a processing compute, and that needs to be analyzed with the AI model, and that result should be saved in a database. That is our asynchronous flow. Whereas for a synchronous flow, we want the responses when users access that API to be as quick as possible, wherein it goes to the backend database and pick the summary of those documents and serve it to the end users. Right? So these are the two key requirements for our document summary app. Let's see how we can go about building that. Okay. This is my AWS console. I'm going to log into Application Composer. This is Application Composer service page. So either we can open a demo project, and for our case, we will create a new project for our document summary app. Now, on this Application Composer page, on the left, you see that what we call as resource cards, and there are of two types. So one is the enhanced component. So the enhanced components could be a combination of one or multiple CloudFormation resource. For example, if we talk about Lambda function, that Lambda function, if I drag and drop into my visual canvas here on the right side, it will, of course, launch the Lambda function. Along with that, it can also contain what it requires in terms of IAM role, the log group where it can emit out the events to, etc. And the other type of resource card is a standard ISC resource. These are the individual components. And as you can see, there are almost 1,149 as on today. You can make use of combination of both. And on the right side, we have the canvas where we can drag and drop these resources to. While doing so, it's going to generate the template as we speak. Right? Let's start with our storage service. For that, I'm going to search for S3 bucket and drag and drop into my canvas the S3 bucket. So if I click on details, we can give the name of what the purpose of this, documents S3, I'm calling it. Now, if you notice here, by default, Application Composer is following best practices by blocking public access to this storage bucket. And also, if I go into the template side of things, it is enforcing the storage encryption by using AWS KMS. At the same time, it is denying traffic which is unencrypted. So it's basically enforcing both encryption at rest and in transit. Okay, we want the summary results to be processed. For that, let's leverage AWS Lambda function. Let's call it process files. Okay, now you see for each resource which we are dragging and dropping, there are the resource properties. This although it has good enough properties, it may not be full exhaustive list of all the supported properties, but you can get started with what you have here, and whatever is not available, you can directly go to the template and add them as well. Okay, I've gave it a process file, Lambda. Either you can define the package type, whether it is a zip or a Docker image. I'm selecting zip here. I'm selecting the source path as well. We can select the runtime. I'm going to select Python. You can select the architecture, so on and so forth. Memory, CPU, provisioned or reserved concurrency, etc. I'm clicking save. Now, as you can see, for each resource card, there are ports, one on the left, and there is one on the right as well. So one on the left indicates which resources can invoke this particular resource, or this particular S3 bucket in our case, and one on the right indicates what this resource can further invoke or pass on that event, thus creating an event-driven architecture. Now, as soon as I click on this particular port, you see that on the Lambda function, the left side of the port is already highlighted, which means that if I do a connection, it is a supported method. So with little guesswork, you would be able to create architectures in this application composer. Okay, as soon as I connected, it did something for us. So what it did is that it has already added a code in our SAM template or in our template saying that it is going to trigger that Lambda function on every object create or removal, right? Which is what exactly we need. We need this Lambda to be triggered when somebody uploads the document in our storage. Okay, let's go ahead and save the results in our database, for which I'm going to leverage Amazon DynamoDB table. I'm calling it summary table. Again, you can go with the defaults or enable your own configuration like sort key or expiration key, etc. Let's go ahead and connect it as well. Once I connect it, again, the same thing. It's basically adding the variables of that table so that when I write or when I build my business logic in the Lambda function, I can refer this table name as a variable, right? And at the same time, it is adding an IAM policy to the Lambda function. In this case, it is creating a create, read, update, delete policy, which is a CRUD policy, so that my Lambda function has enough permissions to read and write to the backend database. Okay, as we talked about our function, it also leverages our application, leverages Amazon Bedrock to do the document summarization. So let's go ahead and give it additional permissions to invoke a model. For that, I'm going to leverage a standard IAC resource in this case. If I drag and drop it here, so unlike our enhanced component, the standard IAC resources, we need to give it configuration ourselves. So I'm going to call it Bedrock Access and give it a permission as a policy document. Perfect. As you can see, the template is it's generating the template as we are dragging and dropping the resources. Okay, let's refer our Bedrock Access here in the policies. I'm giving it two permissions. One is to read from the S3 bucket so that it can access, the Lambda function can access the files. Okay, so this is our asynchronized, the asynchronous flow here, wherein the users, when upload object into the S3 bucket, will trigger the Lambda function. The Lambda function would process the documents and then save the summary in our backend DynamoDB table, right? Now, as this is on the console, we have two options. One is either saving the template locally or activating something called as local sync. So what this local sync does is that whatever we're creating in the Amazon AWS console, it's going to save it in our local file system, from where we can either check it into our version control system where your pipelines will take over, or you can use AWS SAM commands to deploy it. So let's see that in action now. So I'm going to save this in, okay, I'm going to create a new folder, document summary. Perfect. What it's asking me is that it's asking me temporary permissions, the session bed permissions, so that it can read and write the files to my local file system. Perfect. So autosave is enabled. My configuration is saved to my local file system. So what I'm doing is that I will open up my favorite IDE, VS Code. Let me open up the project folder and see what it has created. Okay, perfect. So this is the template which it has created with all the resources which we see. right? So the document S3, the bucket policy, the process lambda, log group, summary table, and bedrock access. Now, as announced this morning, we can actually leverage or use application composer right from VS Code, right? So if I open up the application composer within my IDE, I can continue my application creation right from the IDE. Okay, so we only did half of the application for now. Let's do the other half, which is a synchronous flow or API. So for that, I'm going to drag and drop the API gateway into my console. Okay, let's call it summary API. You can add, authorizers or methods like, for example, get it by ID, etc., for which we don't need it. I'm going to save or use the defaults for now. You can configure the course if you have that, or use external API file definition as well. Okay, perfect. I'm saving it. Similarly, to our process lambda function, let me also do a lambda function for our get summary. Let me call it get summary lambda. Perfect. I'm saving it. Connect both of these. I want this get summary to fetch it from our DynamoDB table. Okay, this is our architecture done. Design is done, configuration is done, template is ready to go. So let's go ahead and deploy this template, for which I'm going to open up a new terminal. Let me zoom in a little bit. Yeah. I'm using a SAM accelerate command called SAM sync to quickly sync or validate this template which we have, build the artifacts, and go ahead and deploy it. I'm going to give it a stack name, or document summary, and specifying the region where it should go, US East 1. Okay, it's basically asking me, okay, SAM sync is generally recommended for a development environment. Do you want to go ahead? For which I'm going to say yes. Okay, it is validating the template, building the artifacts, and also creating the CloudFormation stack set in my AWS account, all with one command. And also you can use a watch attribute to the command which we used, where it will keep syncing all the changes which we do into the AWS environment so that we can quickly test it. So as this would take a few minutes, what I've done is I've already deployed the very same architecture. And let's see things in action where we can test it, right? So what I've done is that I have this template, the very exact architecture, which we have seen just now. And in this case, I also have the Lambda function or the business logic created, or rather generated would be the right word, because I've leveraged Amazon Code Whisperer to write up this particular business logic. So what it is doing in our case is that this particular process Lambda function is leveraging Boto 3 or Boto 3 framework and summarizing the documents which we're going to upload in under 100 words using Bedrock, or in this case, Anthropic Claude model, and saving those in our DynamoDB table, right? And I have a bunch of files here on the left side, so if I quickly check. So these are like project documentation, product documentation, such as EC2, DynamoDB, application composer itself, right? So there are like almost 700-800 lines of documents which we have. So we want it summarized by our application in under 100 words. So let's go ahead and upload these documents and see what exactly happens. Okay, I'm using AWS S3 command to copy this to our storage or S3 bucket. Okay, perfect. The document upload is complete. Let's go to AWS console and see if they're being processed. Okay, I'm using the pre-deployed version is in Oregon, so I'm going to that region. This is the DynamoDB table. And if I check explore table options, slowly, by the time, they're already processed as quickly. I mean, by the time I came here, now you see, Okay, let's pick one of the latest process document. For example, it picked up a Route 53 product documentation, and it summarized in under 100 words what the Route 53 does. Amazon Route 53 is a highly available and scalable DNS system, right? And similarly, if you want to check the API which we have built, either we can go to the API gateway, open up the API, and test it here, which should fetch us all the list of the items in our document DB, in our DynamoDB table, right? For example, this is one. And also, you can use tools like Postman to basically request that. For example, this is the summary for the lambda.txt. There is one for the well-architected application composer, etc. Okay. Coming back to our application composer, although we have created the architecture, deployed the SAM or the template or architecture, tested it all out, we can keep adding more and more resources or changing the attributes right from the application composer so that we can always update our architecture, right? For example, as Emily talked about the amplify for the front end, we can also use amplify, drag and drop here, and then go to the resources and create a front end connected to the backend storage or this S3 bucket and connect it to the API so that it becomes a full-fledged application on its own, right? Also, similarly, let's assume that we talked about documents right now, but what if you have a complex workflow which you need to achieve? For example, that document need to remove any PII before being stored in a backend database. How do you achieve that? For that, you can leverage something called as step function state machine right from the application composer, which is now in VS Code, to go ahead and configure. And you can visually now also, within the application composer console, create the full state machine and create those distributed applications, right? So you can do that. Save. Oops. Yeah. So you can basically replace this Lambda function with a state machine and go through a complex workflow if you have such a requirement, right? Okay, so far we have talked about something which is brand new. What if you may already have a template? Let's see how that will look like. So if I now open up a new window, okay, what I've done is I've picked up a sample project from AWS sample, which is a CQRS, which is a command query response segregation pattern. Let's see how does that look like in our application composer. Okay, this is a massive template with lots of resources. So by just loading that template in my composer in the VS Code, it is showing you visual representation of the whole architecture, how one component is integrated with another, which event is triggering another one. For example, in our case, this particular query item report Lambda function is fetching the data from this database, but it is using RDS proxy to connect to it. So with one single template, you can see the full state of the architecture right from the application composer. Okay, so if I switch back to the So if you want to continue your serverless learning journey, you can use AWS Skill Builder, where you have lots of resources in terms of training plans, video learnings you have, and also you have ramp-up guides with which you can start with your serverless learning journey, and you can earn the serverless badges in terms of serverless or events and workflows, etc. You can find them in s12d.com/serverless-learning. Yeah, as Emily mentioned, you can check out the serverless video, which is built on serverless architecture. It also leverages generative AI titles, and it uses video processing, etc. Okay, all the session resources which we have, which we have talked about today, especially on the application composer, the serverless services, everything, you can find the full list of resources in that particular URL. And more importantly, Application Composer is a free-to-use service. There is no additional charge for you to use Application Composer. It's only that you need to pay for the resources which you deploy using that. In our case, the S3 bucket, the DynamoDB table, the number of Lambda invocations, etc. With that, we want to thank you for your time and joining us today. Hope you found it useful. Please do take a moment to do the survey in the AWS Events app. Thank you so much.